So for question 5, they want us to use truth tables to prove the theorems, the parts of the theorems 1.11, 1.1.1. Now I've put these tables kind of out of order based on the number of propositions that they have. So it might be a little bit messy, but we'll get through. So let's begin with A. So for A, we have that we only have P. So we have the case where P is true and then where P is false. So then not P is false because it's a negation. Negation of true is false, and the negation of false is true. So then it wants us to negate the negation. So the negation of false is true, and the negation of true is false. So when we're comparing these truth tables, we can see that P is logically equivalent to not P because they have the same truth tables. So we have proved item A. So maybe let's put a check mark next to here to just show that we did it. So let's do item B. So we do have to fill out this table with all the combinations of P and Q. Because there are two propositions, we do need to have 4 different rows so that we can really have all the possible combinations of truth values. So we have here true, true, false, false. That was not very pretty. False, false, and then true, false, true, false, and then we'll just put in the negations as well because we'll need them to build up this table. Not P, so not true is false. Once more, not true is false. Not false is true. Not false is true. And now let's negate Q. Not true is false, and then that is true, false, and true. Okay, so let's do the truth table for item B, which is we're comparing the statement P or Q with Q or P. So P or Q, we have true, which is true. And then we have, let's see, true or false, which is also true. Then false or true, which is true. And lastly, false or false, which is false. So remember, whenever we have an or, it's always true unless both propositions are false. Now let's do it the other way around, Q or P. So we begin with true or true, which is true. Then false or true, which is also true. Then true or false, which is true. And then false or false, which is false. So if we compare their truth tables here, we can see that these are logically equivalent, and therefore we can say that P or Q is logically equivalent to Q or P. Now, so let's put in our check mark for item B. Now let's do item C, where we want to prove that P and Q is equivalent to Q and P. So we're doing the conjunction, right? So we have for P and Q, we have true and true, so true. And then we have true and false, so false. So disjunction is false unless both of them are true. So false and true, false, and then false and false, false. So let's do Q and P. That is true and true, true, false and true, false, true and false, false, and then false and false, false. So once more, we can see that their truth tables are equivalent. Therefore, we can say that P and Q is equivalent to Q and P. Now, so let's put in our check mark for C. And let's do H and I. because they also have just two propositions. So for H, we have not P and Q. So we're going to go to, and maybe I'm going to erase all of this. So we're going to go to this column over here, and we are going to deny it. So the denial of true is false. The denial of false is true. The denial of false is true. And once more, the denial of false is true. Now, we are going to, for the second column, we are going to do the disjunction of the third column and the fourth column, which is not P or not Q. So false or false is false. Remember, the disjunction is false when both of them are false. And then we have false or true, which is true, true or false, which is true. And lastly, true and true is also true. So because these truth tables here are the same, we can see that we have proved the logical equivalence, and which is DeMorgan's law. So we've proved the first of DeMorgan's law. Let us put a check mark on H, and let us just write this down. It's always nice to kind of see it spelled out, that not P and Q is logically equivalent to not P or not Q. So now let's do item I. And for item I, what I'm going to do is I am going to, I'm going to negate this column over here. So the fifth column, I'll begin by negating the fifth column. So let's see, we begin with true, so the denial of true is false. And then we have here, so false. And then we have the denial of true, once more, false. The denial of true is false. And then the denial of false is true. So now let us do the conjunction of the third and fourth column. So we're going to join these with an AND operator. So false and false is false. False and true is false. True and false is false. And then, true and true is true. So we compared not P or Q. So I'm going to write this down, not P or Q. And we can see because their truth tables are the same, these statements are logically equivalent. So we can say they are equivalent. So that is not P and not Q. So we have proved the other of DeMorgan's laws. So now let's go to the longer problems. Let's go to item, and let's see, I skipped one item. Yeah, so I did just D. I believe that I skipped E because it was not very interesting just to do a second of the associate laws. So let's just fill out this table over here. Now this is quite long, so we'll have to have a little bit of patience. And now because we have three propositions, right? We have P, Q, and R. The truth table must have 8 rows so that we can account for every single interaction between them. So this is true, 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 and true. And then false, 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 and false. Now we have, I'm just going to make this look a little bit better. False and false. And then we have true, true, false, false, and true, true, false, false. And lastly, now we just alternate between true and false. So we're going to have to build up, because these are lengthy compound statements, we're going to have to build them up bit by bit with like smaller chunks. Because if you were to do this all at once, it would be very, very likely that you would make a mistake. So first, let's do Q or R, which is the disjunction. So we're comparing, actually, we're joining the second and third column. So we're doing true, true or false is true, false or true is true. And then, let's see, false or false is false. Then true, 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 false. Now, we want to do P or Q. So we're doing the disjunction of the first and second column. So we have true and true, which is true, true and true, which is true, true and false, which is also true, true and false, true, and then true, true, and now the last two are false and false and false and false. Actually, false or false, because we're using the disjunction still. Yeah. So now we're ready to join these. So what we're going to do is we're going to, for the first column in green, we're going to use the disjunction operator on this column over here, P, or Q or R. So the disjunction of these two columns, the first and the fourth. So I have true and true, true and true. Remember, I'm doing the first and fourth. And then I have, let's see, true and true. And then true, true or false, which is true. Sorry, I think I said true and true earlier. I meant true or true. And then I have false or true. So true, false or true, true. And then false or true, true. And then false or false, false. So all true except the last line. So now let's do we're doing the disjunction of P or Q. So of this fifth column with R. And I put an added bracket where it wasn't supposed to be. So I'm just kind of going to remove this for now. So P or Q conjunction with R. So P or Q or R. So let's apply the conjunction operator with the third and fifth column. So true, false or true is true, true or true, true, false or true, true, true or true, true, false or true. And then you have true or false. And then lastly, we have false or false. So we can see that these are equivalent, right? We can say that because the truth tables are the same, we can say that P or Q or R is logically equivalent to P or Q or R. So this was item D. Now let's just go back up and put a little check mark here. Let's see what else we have. We have to do F and G. Actually, I put a check mark, but accidentally, it should have been an H. Okay, so once more, we're going to have to build up these intermediary statements so that we don't do it all at once, because easy to get lost. So let's do Q and R. So for Q and R, we're taking the conjunction of the second and the second and the third column. So for the conjunction, we have true and true, which is true, and then true and false, so false, then false and true, which is false, false and false, false, true and true, 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 false, 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 true, false, and lastly, both are false. Let's do now P and Q. So the first column and the second column, so a conjunction. So now for the first two, we can see that both of them are true. So we have true and true. And for the last 6 rows, all of them contain a false, either one or the other. So we know that because it is a conjunction, all of these will be false. So we can go ahead and put that in. And lastly, let's do P and R. So it's the conjunction of the first and the third. So we begin with true, and then we have true and false. So false, true, and true, true, then true and false, 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 true, false, 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 true, false, false. So yeah. And now we want to do a conjunction of, let's see, conjunction of the first column with Q or R, with the fourth. Yes, conjunction, because before we did a disjunction. So let's see. The first and the fourth. So that's true, true. And then we have true, true. And then we have true, true. Then we have true, false, which is false. And then all the remaining rows are false for P. And since we have a conjunction, it means that this statement will be false too. Now let's do the conjunction of, let's see, P and Q. So this column, and then the disjunction, of P and Q with P and R. So these two columns. It's nice that they're right next to each other, so easy to see, right? And because it is a disjunction, it will be true when either of them are true. So true, true, true and false, true, false and true, true. And now we just have false all the way down for both of them. So all of these are false. And we can see that the truth tables are the same. So we have the statement P and Q or R is logically equivalent to P and Q or P and R. So this is one of the Boolean distributive laws. So item F, we just proved that they are equivalent. Let's put a little check mark here. Let's see what we're missing. And then we're just missing item, let's see, G. Yeah, I didn't do item E. So for item G, let's see what we have. First we have to do this auxiliary truth table, this auxiliary statement. So now we have the conjunction of P and R. So that is the first column or the third. So we have true, 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 and then let's see what we have. True, false, true, false. Okay. And now we have to do for this column over here, it is the conjunction of, let's see, it's the conjunction of P. So the first column, P or Q and R. Where is Q and R? So the first column and then this column over here. So these two. And it is P or, so a disjunction. So wherever we have true, we're going to put true. So I know that the first four are going to be true because P is true for the first four. And then now let's see Q and R. And then it's true over here. And the last three are false. Yeah. Okay. Now let us just complete the last column. So the last column wants us to have the conjunction of P or Q. Where is P or Q? P or Q, which is over here. This arrow over here. And then P or Q, conjunction with P or R. Where is P or R? Oh, here, the new one that we did. So, and actually this looks weird. I'm just going to put this arrow over here. So we have to do the conjunction, right? See where they're both true. So the first one, true for both, and then true for both. And then let's see, true for both. And then for the fourth row, true for both. What about the fifth as well? And then the last one is, let's see, false, because we have a true and false. So false, and then we have a false and true, so false. And lastly, we have a false and false, so also false. And now we can see that their truth tables are equivalent, are the same. So we can say that the statement P or Q and R is logically equivalent to P or Q and P or R. So we have proved that, and now let's just put a little check mark here. So we have proved using truth tables that all these statements are equivalent. So I'm just gonna zoom out so that you guys can see the whole thing at once. If you need to take a screenshot of it, and yeah, that's it.